All right, guys, so today our focus is going to be on polar points and polar equations. And just as a quick note about scheduling, this is our last section for Unit 3. So I'll be talking a little bit more at the end of today, maybe in part 2 after we take our break, about pacing, assignments, and tests. But the good news about this section is we're going to return to some of the concepts that we saw with complex numbers, but we're not doing complex numbers. So it'll feel familiar and also help us out with that section. One of the comments that I had on the Desmos activities for the complex numbers was, oh, I'm having trouble converting from standard form from a complex to polar form or polar form to standard. Well, what we're going to do today is practice more of that with real numbers. So in more trig form, you're going to see that polar form and trig form, people sometimes use interchangeably depending on the setting. So we're gonna kind of get better at that. I also do plan later today. Sometimes I plan and then get behind, but I plan to do a video going over the card sort that was in that complex numbers activity on Desmos, just to make sure that everyone gets that right. That was one of the comments that you would like to know if you got it right. And I think it'll be easier to do one video than kind of troubleshoot each one. But I think after this, if you were struggling with that, you will be in a little bit better shape. So let's go ahead and talk about, first of all, something that's very familiar to us, the rectangular coordinate system. So the rectangular coordinate system is just the regular XY axis system. Sometimes we don't say rectangular system, but just the regular XY axis system. So why do we call it the rectangular? Well, because think about our grids are rectangles, specifically squares if we're making these equal. But think about if your scalings are something like 0, 1 on the x-axis and 0, 10, 20, 30 on the y-axis, then if you kind of put it to scale, these aren't really squares, they're rectangles. Sorry, guys. But even if we do equal scaling, ones and ones, then it's still the rectangular system. So we understand it very well, and we understood how to take the rectangular system and transfer that knowledge over to the complex plane, thinking about it very similarly. But all throughout the semester, we've been dealing with the unit circle and thinking about how to go around the unit circle if I give you an angle, and then extend to bigger circles with expanding the radius, and then continue to have a radius and an angle, and kind of flip between that radius and an angle and an X and a Y. So we've been kind of dancing around the idea of polar systems for a while. We just haven't called it that. So let me give you an illustration. Let's say we take the point 2, 2. Okay, so 2, 2 is a point, and that point has a certain distance from the origin. I'm going to just highlight that in red. If you think about that particular point being on a circle, you can imagine that circle, right? And we can say, hey, if I think about this picture, another way to describe where 2, 2 is to tell you the radius of the circle and the angle that we're forming. Now, in this case, the angle that we're forming is probably the easiest part. Because of the symmetry, the 2, 2, we've got a pi over 4, or a 45-degree angle. And then the radius might be a little bit trickier. If we think about drawing the corresponding right triangle over here, we've got 2, 2, over 2, up 2. And then our radius, if we work it out, we would get 2 squared plus 2 squared. So 4 plus 4 gives us 8. The square root of 8 reduces to 2 square root of 2. Or you might remember from your special 45, 45, 90 right triangles, we've got the side times the square root of 2 for that hypotenuse. So all of this tells me if I know a radius and I know an angle, it gives me the same position. So that was kind of the same idea that we were looking at with the trig form, that if you had a 2 plus 2i, thinking about the complex plane, then you could find the complex polar form or the complex trig form. So what we're going to transition to is to describe our point with just these two pieces. So we actually have done it. And then we're going to think about a new coordinate system that's geared towards this representation. So I'm going to put it in yellow because when I say 2, 2, 2, 2 is a description in the rectangular system. Then when I describe just the two pieces that give me the same information, 2 square root of 2 and pi over 4, this is going to be a polar point, or a point in polar form, okay, where the first component is telling me a radius and the second component is telling me an angle. Now, you need to indicate when you are using polar form, kind of like I did here, or if you're in an entirely polar section, everything would be polar. But it's not the same as going over 2 square root of 2 on the x and up pi over 4, which, see, I always remember pi over 2 is about 1.57. And so this is close to 0.7 for pi over 4. But if you think about that, it's not telling you to go over and up on a rectangular system that much. It's telling you the radius and the orientation of our rotation. So when we think about describing things with polar coordinates only, it is much, much easier to graph a polar grid. So here's a polar grid, or the polar system. We're going to start with the exact same, maybe not the exact same one, but start with similar examples. If I give you a radius and an angle, you can plot it. Now, in the previous example, maybe not the greatest one for me to pick to start with, this radius is not a whole number, which means it's a little harder to visualize. Hold on to that thought. So let's say I know I'm in the polar system, and I tell you, you have a polar point. Again, I'm gonna let's say we do 4 pi over 3. So this is telling me my radius and my angle. Notice your radius in this case, or I should say your radii, are concentric circles. A radius of 1, our unit circle, is given by our first tick mark, but then the entire circle all the way around. Okay, so what's highlighted is my unit circle. I want to focus on that polar point for a second. So if you think about a radius of 3, that's going out to 3, and a radius of 3 could be anywhere on that circle with radius 3. But as soon as you tell me the angle, that fixes where my particular point is. Now, let's plot it. Okay, 4. So 1, 2, 3, 4. It's kind of sometimes hard to make sure you're in the right place here. So 1, 2, 3, 4. And then I'm going to take that up to pi over 3. And then that's my point. So I'm going to put my point in purple to make it really clear. That is the point that I'm looking at, and kind of erase my scratch work. All right, so I found a clip on the internet with degrees and radians, which kind of makes this a little bit easier. So let me stop a minute and ask, what questions do we have with plotting this polar point? Okay, so I don't see any questions. So just a couple things to re-emphasize. It is a point. So it's a single point in space. It's not like the whole circle. So let's go ahead and plot a couple more polar points. Now, if I think about maybe another example, and try to maybe make my colors a little bit more consistent. Actually, let's fix that. Let's make that one red. Okay, there we go. So if I do another point, and I think about 2, negative pi over 2. It's not a problem to have negative angles, and most of the time we're going to think about if it's a negative angle, maybe where that would be with a positive orientation, but we understand negative pi over 2. So in this one, we're going over to radius 2, and then we're going to go down to negative pi over 2. Because the point that we're looking at is right here. Now let's do one more, and then we'll kind of pause and talk about these. Let's go ahead and say that I have negative 5, and I'm looking at something like pi over 3. Okay, so we already know, if I kind of start with this angle first, the pi over 3 is right here. But this idea of a negative radius can be a little bit tricky in terms of visualizing in this particular case. When you're talking about a positive radius, you're usually talking about a particular geometric shape. We don't talk about a circle with a radius of negative 2, but it's possible to think about this. So think about what you might think this is. So I want you to take a minute, and I know it's kind of hard to describe in your chat box, but like, what would you think this means? Okay, so I'm going to give you a second, and I'm just going to check and make sure one other thing is working. Type in your response. Don't worry about being wrong. You can send it privately. You can send it to everybody. I have no idea is also okay, but try to think about where you think that would be, and then write a description. Okay, guys, I'm going to plug my computer up really quickly. I had it die mid-Zoom meeting last time, which was terribly embarrassing. That is not going to happen this time. I'm terrible about not plugging my devices in.
I know why.
Oh, it got unplugged from the wall.
Mom, it got caught under there.
Yes, my little one is having trouble.
So when you turn it, it's going to bite.
Yes, do not run your chair over. I'm having cord issues here. Sorry, guys. You don't get to see real life. Just me having tech issues. And it's going to be recorded for all of YouTube for all of eternity. Wonderful. All right. So let me just double check the tech that I was looking on before. Okay. So lots of I don't knows, which is totally fine, right? Like, what are they even talking about? Okay, so a couple things like a reference angle, somewhere having to do with a radius of 5 still, but like where that is kind of tricky. So you guys are actually kind of on track with this is weird, right? But it's saying to think about moving in, if we think normally, let me grab my iPad here, that'll be easier to illustrate. If we think about our radius normally, we're going in what we would think the positive x direction. So if we think about a negative radius, it kind of makes sense to us that maybe that should be somewhere out here, which is kind of what's going on. So if we think about starting with our negative 5 and then a pi over 3, it is kind of thinking, let me count these out, 1, 2, 3, 4, 5, and then using a reference angle of pi over 3. I'm going to show you kind of how Desmos handles this in a couple minutes, because there are some interesting things that happen. In terms of this one, but let's actually kind of return to this one for now, right? We're going to say, why is this not working? It kind of combines some of this. Sorry, guys, I'm looking at my screen. I'm trying to figure out why this is not seeming to do what it's supposed to be doing on my screen on Desmos, because I want to share that with you. Okay, so sorry, guys. All right, I'm going to troubleshoot Desmos in a second because it's not going to work for the sharing. So where I want to leave you with it right now is thinking about like where this is going to be and then kind of combining this with our angle. All right, so while I'm troubleshooting Desmos, because I would like to share this screen, I'm going to give you a couple to try. And what I want you to do is just sketch these using, like, just kind of sketch your own picture for these. Let me give you a couple to do. You're going to assume, and I just gave you a blank polar coordinate so you could use it to help you. I'm going to give you 3 that I want you to plot. So let's do 2, 9 pi over 2. I want you to do 4, negative 60 degrees. And then I want you to do 1 and 5 pi over 4. Okay, so plot those 3. These are all in the polar system. And I'm going to try to figure out why Desmos is not cooperating with me really quickly while you guys are doing it. Okay, so I'm looking at some of this Desmos coding and it doesn't seem to be, not sure why my thing is not working on Desmos to share with you guys, but let's go ahead and go over these 3 and then we'll go back to that negative radius and I'll just show you here and wait on the Desmos. So let's think about this 2 and then 9 pi over 2. So first thing I would probably do is simplify this 9 pi over 2. I know that this is not between 0 and 2 pi. Think about this is really 4.5 pi. So if you went 4 pi, you're kind of back at the start of your circle. And then you've got another half pi, which puts you back here. But we need to make sure we're the right place. So we're kind of at the pi over 2 position, but we need to be at a radius of 2. And so that one looks in the right place. And then you have 5, negative 60 degrees. So we understand what it looks like. I'm going to do this one in green. To be a radius of 5, 3, 4, 5. And then negative 60, right, if we think that this one would put us at a positive 300. I'll just lose where I am. 3, 4, 5. We are right here. And then a 1 and 5 pi over 4. So 5 pi over 4, think about this is 1 1/4 pi. Sometimes that helps me out. So I'm going to be at pi and then another quarter. And so that's going to put me 5 pi over 4 is here. And then this is actually going to be on the unit circle. Okay, so just reverting that to work, these 3 points. Any questions here? Okay, so what I'm going to have you guys do is go ahead and just, if you have a blank Desmos page, let me actually go back into another Desmos page. And normally when we open up Desmos, Desmos says, hey, I think you're thinking about rectangular form. So I'm going to switch over straight to Desmos in the share. And then I'm going to share my Desmos screen. Sorry, guys, I know it takes a little bit of time here. But here's our Desmos page. Okay, so normally we're thinking about rectangular coordinates already. And we have to tell Desmos if we want to think in terms of polar. So let's choose this arrow. And if you change from rectangular grid to polar grid, you're now in polar form. Okay. Now, keep in mind, you can also toggle between radians and degrees. So we can visualize this pretty quickly, and Desmos is awesome for this part. If we're wanting to plot polar equations, that can help us out. So what I'm going to have you guys do right now is we are going to go into a Desmos activity. So you can go ahead and go to student.desmos.com, and I'm going to move our pictures, and I'm going to share the activity that I want you guys to try logging into. So if you can't log in right now, it's not a big deal, but here's our code, capital, the wrong capital, DF7V3H. Go ahead and get in there. I'll give you a second. And we'll try a few of these together, try matching the points, make sure we don't have any problems. And then we'll go ahead and just kind of continue. I think we're pretty good on points at this point. I just want to check a couple, make sure I see results. And then we're going to take a look at polar equations, kind of the second part of what's going on. Okay, so I see some of you guys in. Go ahead and try the first couple slides, and then I'll stop you. If you're at home and you're watching this, go ahead and log on and try, and then pause the video if you need to, and we'll kind of get that together. Okay, so I'm gonna peek at what you guys are doing. You can kind of keep on your own. And then I'm just gonna make sure we are kind of good to go. It's kind of interesting. We're gonna think about polar coordinates in terms of birthdays and rotations with birthdays. Kind of a cool way to think about it. Guys, you can ignore kind of what I'm doing. I'm just looking ahead to see how far I need to be to stop you guys. So I'm going to let you guys continue. I'm going to pace it right now. If you're at home, the pacing won't be on later, but the pacing to number 4. So I want you to work through those ones. I'm going to restrict you to slides 1 through 4, and then we'll take a look at 4 in just a second. I'm going to look at what you guys are doing so far. You guys kind of get a view of what I see on the teacher mode too, if you're watching this video later. And this is really interesting. Everyone's kind of on the birthday still. Notice you guys all kind of have the same radius or very, very close to it, right? Think about everyone's not exactly the same age because you were thinking about that radius isn't exactly like 17 or 16 or 18. You might be 16 and a half, or if you're using those days to calculate your fraction. But in terms of my circle, right, I'm out way out here, like double you guys, maybe more than double you guys between the 30 and the 40. So I would be out here, and let's see, my birthday's in February, right? So I would be kind of in this first beginning part. It's pretty cool, right? We can oftentimes think about something we might have represented in non-math form, like with this new system. All right, so it looks like people are starting to get to slide 4. Keep going. Take a few minutes, work through slides 3 and 4.
I read 2 books already.
You guys hear my little one there? I'm going to mute myself real quick and just say a quick few things to him and then be right back to talk about these 4. And guys, as you see some of these polar graphs happening, keep in mind on that table, they didn't tell you exactly which ones to do first. I think we're almost all to slide number 4. I'm going to try one of these. Kind of fill these in as well. All right, so let's see. If you are on slide 4, you may realize that you can test your points. And if you haven't tried hitting that test your points button, go ahead and do it. So here, if you take a look at the screen again on mine, if I tried the one, I was going for the orange, I put 0.2 and then pi, and then I hit test my point. And what's going to happen to that is it's going to go to the correct radius, go to the correct angle. And if you're correct, it's going to line up. Okay, so it's kind of self-checking in that way. Pretty cool. Okay, so what I want to do is just pause for a second. I know everybody's kind of still working on slide 4 or potentially slide 3, but I want to take you back. Keep working. I'm going to change my screen share back to my iPad, and then I will go over that negative radius example. I was trying to troubleshoot so I could show it to you better on Desmos, and I think I found what I was doing wrong on there, but I want to finish that one and make sure I don't leave you hanging on that example. All right, guys. So give me your attention just a second back over here, and then we almost time to take a break. So I want us to go back to this -5 and square root of 3. We were talking a little bit about this -5 idea, and then pi over 3, not square root of 3, pi over 3 angle. So some of you were thinking about reference angles, negative things, like how all this works. And all of those are kind of right ideas to think about. We can think about a negative radius, like I was mentioning before, as going in the opposite direction to start. In this case, kind of this direction. So we're going to go 5 over, and I'm going to do this in black on this one. 1, 2, 3, 4, 5. And then think about from there, you're going to be over the pi over 3 degrees. So we're going to investigate equations more when we come back. But this entire pi over 3 right here represents the pi over 3 angle. So what we actually do is we're -5 on the pi over 3 line. Think about these angles are entire lines. More on that to come. You're right here. Now, some of you may notice, if you're thinking reference angles, you are looking at a reference angle of pi over 3, right? Because your reference angle goes from the x-axis. And here is your polar point. Now, I was investigating a little bit in Desmos. We're going to work on polar equations next. And even though Desmos does a polar grid, there's a couple things that Desmos doesn't do. It doesn't really recognize these polar points in terms of expressing them like this in Desmos very well, which is, I was forgetting about that aspect, which is a little embarrassing. I'm not a Desmos pro, you see. I was forgetting about that aspect and how to make Desmos do what I knew it should be doing, and it wasn't doing for me. So what we're going to do right now, you may have noticed that it's going to try to boot us with that 40-minute limit. I'm still trying to get that, folks, you guys. But we're going to take a short break. And I want you to, if you have extra time, try to get through that slide 5. If not, just take a break. And then we're going to pick up at 10:45. We'll restart the Zoom session. I'll restart it a few minutes before that, like 10:40 or so. Get back on and we'll do part 2. All right, guys. So I will see you in a few minutes. If you have any questions too, think about those and we'll take those first. See you in just a few.